Hey guys, so today we're going to go into lesson 6.6, which is on page 193. I'm going to do things a little bit differently today. I'm not going to use your textbook to fully explain this lesson because your textbook is mostly giving you a lot of activities. And so instead of using your textbook, I'm going to be explaining what you need to know about this lesson using a couple of activities of my own on a dry erase board. So we're going to be on page 193. That's where your lesson starts. However, just keep in mind that I am doing things a little bit differently today. Up until now, we've talked about all sorts of things. What you'll need to know for this lesson is how to graph a line using slope-intercept form. That is the basic way that we have been discussing lines right now, and so you'll need to know how to identify slope and identify intercept and how to use that information in order to graph a line on a coordinate plane. So that's what we're going to do today, and so please make sure that you have some graph paper with you, a pencil, and that you are going in and taking full notes on this so that anything that you have a question with or you feel like you're struggling with, you can go ahead and ask them in class. Alright, so I'm going to go ahead and switch this over. Alright, so just so you guys can see, we are on lesson 6.6, which starts on page 193. Our essential question for this lesson says, how are changes to the parameters of a linear function reflected in its graph? So what we're going to be doing is discussing what parameters means. So basically, the parameters meaning, are we changing a slope? Are we changing an intercept? And what that graph looks like once we've changed it. So I'm going to use a dry erase board that has a graph on it, okay? And in this way, it makes it a little bit easier for us to go ahead and start switching in between some graphs. So first things first, if I have a regular function, let's say f of x equals x, you guys already know that f of x is the same thing as having y, so we really have y equals x. Now if I wanted to graph this, I can use an x and y table, and sorry, I put two x's there. I can use an x and y table to go ahead and substitute values for x to solve for y. So this one's very easy because there's not a whole lot of calculations going on. So if I substitute a -1, 0, and 1, if x is -1, then my y is also -1. If x is 0, my y is also 0. And if x is 1, my y is also 1. So if I go ahead and I plot those points right here, alright, I've got -1, 1, so I come over here to -1 and down 1. And then my 0, 0, and then my 1, 1. You guys can see that your line is going to look something like this. My line's a little bit crooked, but you guys get the idea. Okay, so if I go ahead and I do a +1, actually let me go ahead and draw this in black so you guys can see, and I'll do the line in a different color. So if I go ahead and I do a +1, okay, this now looks like y equals mx plus b. Alright, and how do you graph a line that is in slope-intercept form? Remember that the first thing you want to do is plot your y-intercept, which in this case is 1, okay? And so I'm going to come up here to +1 on my y-axis, and then my slope here you see is 1. So that means I go up 1 to the right 1, up 1 to the right 1. All right, so my line looks like this. Now notice that my line looks almost exactly the same. The only difference between this line and the original line that I graphed is that it has been shifted 1 unit up. Every single point has been shifted 1 unit up. Okay, let's try another one. Okay, so I'm going to go ahead and I'm going to put our first original function, which was f of x equals x. Okay, and so this line right here is our first and our original function. So I'm going to introduce to you a new vocabulary. This is our parent function, okay, because it's our original line going straight through the origin at 0, 0 with a slope of 1, okay? That is our parent function. Now, if I wanted to graph f of x equals x minus 3. Again, this is the same as having it in y equals mx plus b, where negative 3 is my y-intercept, and 1, because remember we have an imaginary 1 here, is my slope. So I'm going to plot my negative 3. So I'm going to come down 1, 2, 3. And then again, my slope is positive 1, so I'm going to go up 1 to the right 1. Up 1 to the right 1. And that right here is my new line. Okay, and again, as you can see, the only difference here from my parent function to my new function is that every single x point has moved down 3 units. So this point moved down 1, 2, 3. This point moved down 1, 2, 3. This point 1, 2, 3. So they have each gone down by 3 units. So now what happens if instead of changing my y-intercept, what happens if I use a different slope? So let's say I have a slope of 2x. Okay, so my slope now is 2. My intercept is still 0. So this is also the same as having 0 because it's going through my origin. Okay, so since there's no number here for b, it's the same as having a 0. So what I'm doing is now I'm going to use this parent function of f of x equals x, and I'm changing my parameter of slope. Okay, so now my origin is still 0. And now I'm going to go up 1, 2, and to the right 1. And then again from this point, I'm going to go up 2 and to the right 1. Okay, now if I want to go backwards to find a couple of points that come before this, I'm going to do the complete opposite. So from here, I went up 2 and to the right 1. I'm going to go from here, I'm going to go down 2 and to the left 1. And then down 2 and to the left 1. Okay, and now using those points, I'm going to go ahead and make my line. So you see now that my line is still crossing through the exact same intercept, but now because my slope has changed, the steepness of my line has also changed. Okay, my line now is going a little bit higher up. So think of a mountain. It would probably be a little bit easier to walk up this mountain than it is to walk up that mountain because this is much more steep. Okay, so your slope, and this is something that you should be writing down, your slope is going to change the steepness of the line. All right, so let's go ahead and try and do a different line using a different slope. So let me get a different marker, and we're going to use another slope and see what that line now looks like. So if I now have a line of f of x equals, sorry, this marker is pretty bad. Let me get another one for you. My apologies. So if I have f of x equals, let's say, 1/2 x. Now again, if I have f of x equals 1/2 x, that is also the same as having a plus 0 intercept. So my intercept is still going to be here at 0, but now I'm going to go up 1 and to the right 2. Up 1 and to the right 2. Up 1 and to the right 2. Okay, and just as I did with this line, I want to plot a couple of points backwards so that I get a full line. Okay, so I'm going to start back at my origin, and instead of going up and to the right, I'm going to do the complete opposite. I'm going to go down and to the left. So I'm going to go down 1 and to the left 2. Down 1 and to the left 2. Okay, and now that's the one that I'm going to go ahead and in blue, I'm going to put these points and graph that. Okay, and so now you see, sorry.
Alexander Montero, please report to Middle High Office. Your right is leaving. Alex Montero, your right is leaving.
Sorry, guys. Okay, so as you can see now, when I have a fraction as my slope, my line is even less steep than my parent function. So when I had a whole number as my slope, my line was much more steep. So it was slanted way high. Now with this blue line and this fractional slope, my line is a little bit lower. Okay, so you can see that by changing just the slope, your line is now shifting up or down. Okay? So what you need to know for this lesson is that your slope is changing the steepness. Okay, so it determines, and this is something you should be writing down, it determines steepness of line. Okay, however, your y-intercept is changing the position of where it begins. Okay, so it's moving the line, it's shifting the line either up or down. Okay, so the y-intercept shifts the parent function, because that's our original function, so shifts the parent function up or down. Alright, so please make sure that you guys are writing that down. You need to know that information. If you guys flip over to page 196 of your textbook, you'll see that it gives you those 3 definitions that I mentioned in this video. They mention family of function, which actually that one I didn't really go into. I apologize. Family of function actually is exactly what we just did right now. All of those lines, they're all connected because they all stem from the same parent function. Okay? So parent function, has to do with the set of functions whose graphs have basic characteristics in common. So the first graphs that we did, we changed the intercept. Okay? And then the second graphs that we did, we changed around the slope. So what I want you guys to do for your homework, I want you guys to look at the guided practice on page 198, and I want you guys to try and complete that. Okay? And that's it for this video. I hope that you guys had an easy time following what I was doing for this video. Hopefully you guys understood it. Please, as I've mentioned before, you should be taking notes throughout this entire video, and any questions that you have, please make sure to write them down and ask them in class, or feel free to email them to me, and that way I can go ahead and answer any questions you have. I'll see you guys with the next video. I hope you had a great time, and I'll see you.